Good morning, everyone. Today I'm going to explain the topic sound. Production of sound. Sound is produced due to the vibration of objects. Let us take an example here. When the stick is hit on the drum, it vibrates and then it produces sound. Now you people would be thinking what vibration means. Vibration means the to and fro motion of an object. Other examples of production of sound are the sound of human voice is produced due to the vibration of the vocal cords, and a stretched rubber band, when plucked, vibrates and produces sounds. Musical instruments. A musical instrument is a device created to make musical sounds. Let us take an example here. Let us look at this guitar. When the person pulls the strings, it vibrates and then it produces sound. And let's look at this drum. When the stick is hit on the membrane of the drum, it vibrates and produces sound. From this we get to know that musical instruments are created for producing sounds. Musical instruments and their vibrating parts. Musical instruments like veena, sitar, violin, and guitar produce sound from their stretched string. Now you people would be thinking, how is it possible? When the string is stretched, first it vibrates and then it produces sound. Vibration means the to and fro motion of an object. Musical instruments like drum and mridangam produce sound from their stretched membrane. And musical instruments like flute and mouth organ produce sound from their air column. Propagation of sound. Air is the most common medium through which sound travels. When a vibrating object moves forward, it pushes and compresses the air in front of it, forming a region of high pressure called compression. Let us understand about it by looking at this animation. Here we see that the object moves forward and then it pushes and compresses the air front. As you can see here, pushes and compresses the air front. And then what happens? It forms a region of high pressure. Let us look at this. See, this is the region of high pressure, which is called compression. The compression moves away from the vibrating object. When the vibrating object moves backward, it forms a region of low pressure called rarefaction. Here you can see that the object moves backward. What happens? It forms a region of low pressure, which is called rarefaction. Now you would be thinking, what means the propagation of sound? When the object vibrates, vibration means the to and fro motion of an object. It produces a series of compressions and rarefaction. Compression means moving forward, and rarefaction means moving backward in the air, which makes the sound to propagate in the medium. Here the medium is air. The medium can also be taken as water. Time period of sound wave. The time taken to complete one vibration in the density of the medium is called the time period of the sound wave. One vibration means the to and fro motion of an object once. It is represented by the symbol T. Its SI unit is seconds. Amplitude of sound waves. The maximum extent of vibration of the vibrating body from the mean position is known as its amplitude. Mean position here is this line. It is represented by the letter A. You can see wavelength. So what wavelength means? Wavelength is the distance between the crests of two waves that are next to each other. This means amplitude. And this means wavelength, as I said it right now. Frequency of sound wave. What is frequency, you people would be thinking? The number of vibrations made by the vibrating body in 1 second is known as its frequency. Vibration. So let us take an example here. First, I will repeat it again. Vibration means the to and fro motion of an object. Let us take an example, which is drum. When we hit the stick on the drum, it vibrates. And the vibrating body here in this example is the drum. So the number of vibrations made by the vibrating body in 1 second is known as its frequency. The SI unit of frequency is hertz. A frequency of 1 hertz is 1 oscillation. Here is a question for all of you. It is, if an object oscillates 20 times in a second, what would be its frequency? The answer is that if an object oscillates 20 times in a second, the frequency would be 20 hertz. As the SI unit of frequency is hertz, that is why we used hertz here, and a frequency of 1 hertz is 1 oscillation. Now, people would be thinking, how is high frequency and low frequency is produced? Short wavelength means lots of waves, as you can see here. Many waves are there here, and which produces high frequency and high sound. See here, this is short wavelength, and there are many waves here. And you can see that this is the frequency, and it is a high frequency which produces high sound. Long wavelength, which is this, you can see here, it is long wavelength, which means fewer waves, which produces low frequency and low sound. What is the difference between these two frequencies? Difference between short wavelength and low wavelength frequencies. The difference between short wavelength and low wavelength frequencies is that in short wavelength, high frequency is produced, and in long wavelength, low frequency is produced. Next is pitch and loudness of sound. The pitch of sound, which is the shrillness or flatness, depends on the frequency of vibration. What is the frequency of vibration? Frequency of vibration is the number of vibrations made by the vibrating body in 1 second. If the frequency is high, the sound has high pitch. See, first we discussed that when there are low wavelengths means when there are short wavelengths, there will be many waves which produce high frequency and which produce high sound, and it also produces high pitch. And if the frequency is low, how is the frequency low? When there are many long wavelengths, it produces low frequency, and then it produces low sound and also low pitch. Next is how is loudness related to amplitude. Loudness of sound is proportional to the square of the amplitude of the vibration producing the sound. Example, if the amplitude becomes twice, the loudness increases by a factor of 4. The loudness is expressed in a unit called decibel. The loudness of sound depends upon the amplitude of vibration. Amplitude means the maximum extent of vibration of the vibrating body from its mean position is known as its amplitude. If the amplitude is bigger, the sound is loud, and if the amplitude is bigger, the sound is also soft. As you can see here, this is the mean position. Next topic is structure of the human ear. The outer ear called pinna collects the sound waves. The sound waves passes through the ear canal of a thin membrane called eardrum. The eardrum vibrates. The vibrations are amplified by the 3 bones of the middle ear called hammer, anvil, and stirrup. The middle ear then transmits the sound waves to the inner ear. In the inner ear, the sound waves are converted into electrical signals and sent to the brain through the auditory nerves. The brain then interprets the signals as sound. So here what happens is this is the pinna, which is the outer ear. What is its function? Its function is that it collects the sound waves. Then next is that the middle ear, which is called hammer, anvil, and stirrup, amplifies the vibrations. You can think that these are the 3 bones, which are called anvil, hammer, and stirrup, which amplify the vibrations. And this is the inner ear, which converts the electrical signals and sends them to the brain through the auditory nerves. Then what does the brain do? The brain then interprets the signals as sound. Audible and inaudible sound. Audible sound is sound which we can hear. It has frequencies between 20 Hz and 20,000 Hz. Hertz is the SI unit of frequency, and frequency is the vibrations made by the vibrating body in 1 second. Inaudible sound is sound which we cannot hear. It has frequencies less than 20 Hz and more than 20,000 Hz. The sound whose frequencies are more than 20,000 Hz is called ultrasonic sounds. Some animals, like dogs, can hear ultrasonic sounds, and the sound whose frequency are less than 20 Hz is called infrasounds. Noise and musical sound. Noise means the unpleasant sounds. It is produced by irregular or non-periodic vibrations. Example, if all the students in a classroom speak together, a noise is produced, and sounds produced by horns of bus and trucks. Musical sound. Sound which is pleasing to the ears is called musical sound. It is produced by regular or periodic vibrations. Example, sounds produced by musical instruments and sounds of a person singing a song. Thank you.